Okay, now a few examples related to the previous chapters. These are actually the solved example of the book which we are following, and these are very short numericals. Example, this is the short example. Look, 2 to 3 lines solution for each example. So the first example is the energy band of a dielectric is 1.02 electron volt, and we have to find the voltage required to transport 10 raised to the power 12 electrons to the valence band. I think we have already solved this example in the slides, but okay, for the repetition. Okay, E2 minus E1 is actually the band gap energy, and which is given, that is 1.02 electron volt, and we have to find the voltage V which is required to transfer 10 raised to the power 12 electrons. These are the number of electrons to be transported from the valence band to the conduction band. Okay, this is actually an example related to the band gap theory. We have this is a valence band. Okay, this is the forbidden band. And this is the conduction band. Okay, and this is E2. This is E1. Okay, so this is actually the band gap energy which is required to jump electrons from valence band to the conduction band. So how many electrons? There are 10 to the power 12 electrons. As we know that uh, electron EV, the voltage that is necessary to jump the electron from conduction band to the uh, valence band to the conduction band. Okay, this must be equal to or greater than E2 minus E1, the band gap energy. So this is for one electron, and for n number of electron, we have n electron volt must be greater than E2 minus E1. So n electron volt must be greater than E2 minus E1, the band gap energy, in order to cause the ionization. So what will be the V? V will be equal to E2 minus E1 divided by Ne. E2 minus E1 given. Okay, E is the charge on electron, and N, N is the number of electrons transported. So very simple, we get 6.3 mega volt. Okay, now the second example, this is actually related to uh, the conductivity. Okay, assuming no heat losses to ambient, and determine the electric field and voltage necessary to produce a conductivity of 10 to the power minus 18 ohm meter at room temperature in a disk of dielectric material with diameter of 1 centimeter and thickness of 5 centimeter. The value of arbitrary constant is 3.5 into 10 to the power minus 8. Okay, so we have the formula of for the thermal. We have this conductivity is equal to A e raised to the power minus Eg divided by 2 kT. Okay, what are the variables? This is the conductivity. Okay, which is given, and A is the arbitrary constant. This is also given. T is the temperature, which is the room temperature. Okay, so it means it is 20 degrees C. Okay, and K is against the Boltzmann's constant. Boltzmann's constant is also it will be given. Okay, that is 1.3 into 10 to the power minus 23. Okay, Boltzmann's constant, and T is the temperature. the room temperature. Ag is the band gap energy. Okay, so we have to find this. We have to find E. Okay, the electric field intensity. E is equal to V divided by D. So in order to find E, we have to know about the V. So first of all, we will find V. Okay. So EV is equal to what? For the for the V, we have to find EG first. Okay. So all of these values are given. We have to find EG from this given data. So conductivity is equal to A. Conductivity is given. A is given. T is given. K is given. We have to find this EG. But this is in the power, exponential power. So how to find this EG? Okay. So first of all, we have to move it on the coefficient side. So for this purpose we have to apply the ln. Okay, so that the exponential can be cancelled out with this ln. So minus eg, apply ln on this side and on this side. First of all, divide it a on both sides, so you will get conductivity over a is equal to exponential this whole thing. Then apply ln on this side and ln on this side. Okay, so this ln will be cancelled out with this exponential, and we will left with minus eg divided by 2 kt. Okay, so minus eg divided by 2 kt is equal to ln of conductivity divided by a. So now putting the values of conductivity, which is 10 to the power minus okay, there is a mistake. This is actually minus 18, and they have put 10 to the power minus 12. Okay, so either this must be 10 to the power minus 12, or there there must be 10 to the power minus 18. Okay, so we have to put 10 to the power minus 18 over there, divided by a is given. This is a arbitrary constant. Okay, so and then apply with 2 kt. So this is 2, this is k, this is t in Kelvin. So t must be in Kelvin. Okay, because the rest of the values are given in Kelvin, so t must be in Kelvin. So 20 degree C means 20 plus 273 to convert into Kelvin. To 20 plus 273 will be equal to 293. So this is actually 293. Okay, and this is the value from this after solving this bracket. So Eg is equal to 8.45. So electron volt band gap energy in term of voltage will be equal to EV. Okay, so we have to find this V. So dividing E on both sides, E will be cancelled out. So V will be equal to Eg divided by charge on electron. Eg, we have find Eg from this formula. Okay, and E is the charge on electron, 1.6 × 10⁻⁹. So we get this much volts. Okay, so we have to find two things: electric field intensity and voltage. So one has been find out, V, and now E. E is equal to V divided by D. Okay, D is actually the thickness. So the thickness of material is given, which is 5 centimeter. This is dia, not that this dia is not applicable over here. Okay, so we have to find only this D 0.05 in meters. So volt per meter will be this. Okay, now switching to another example. Okay, repeat the previous example to find the conduction current. and the resultant current density means J. You have to find I and J. Okay, so conductivity was 10 is power minus 18 in the previous example. So now resistivity is the reciprocal of conductivity, and we need the resistivity values in order to find the I, because I is equal to V divided by R. For this purpose we have to find the R, and according to the resistance law, R is equal to rho L over A. Okay, so for this purpose we have to find the resistivity. So resistivity is actually the reciprocal of conductivity. So if the conductivity is 10 raised to the power minus 18, so resistivity will be equal to 10 raised to the power plus 18. Okay, so the resistance will be RL rho L over A. Okay, this L is actually the thickness, and for the A you have to find pi. The area of the disk will be equal to pi r square. Okay, so the D is given in the previous example, which was 1 centimeter. So from this, pi r square, pi d square divided by 4, pi d square divided by 4, because we are given the dia value. So this is actually the area. So putting d values, pi value 3.14, and the area will be 0.785, and L is actually the thickness 0.05. So from, and the resistivity is 10 is per 18. So after putting these values we will get R, which is 0.06 into 10 to the power 18 ohm. Using the Ohm law, I is equal to V divided by R. We have already find V in the previous example. So actually the data of previous example has to be used. Okay, so I is equal to V by R. From the previous example, V was 0.528. So 0.528 divided by R. From here 0.06 okay, so I is this. Now the current density is J is equal to conductivity into E. This is a formula. So conductivity is given 10 is power minus 18. E has already been found in the previous example, which was 10.56. So 10.56 into 10 is to the power minus 18. This is the conductivity. So we will get the current density by this way. Okay, now this is actually the example related to the Townsend theory. So the Townsend theory, we have formula of the Townsend was actually I is equal to I naught e raised to the power alpha d. Remember? Okay. Okay. So from this example, the ionization coefficient of a gas, we have to find the ionization coefficient of a gas. What does it mean? It means we have to find the alpha. Okay, and the electrode separation D is given, that is 10 centimeter. Okay, D is given. The conduction current in the gas under normal working condition is 0.01 milliampere, which is very low. So it means it is actually this amount of current which is already present in the gap, which is very much low. 0.01 means 1 2 3 10 10 microampere. Okay, which is very low. And the maximum breakdown current, after the breakdown we will get this current. So this is actually the I. So I is given, I naught is given, D is given. We have to find alpha. Again, alpha is on the power of the exponential. So we have to shift this alpha to downward to the coefficient side. So for this purpose, we have to get the help of ln again. So first of all, dividing I naught on both side. Okay, and then apply ln on both side. Ln of this is equal to ln of E alpha D. Okay, So alpha d will be shifted to the coefficient, because the log rule is the power of any variable having the power can be shifted to the coefficient. So ln of e will be equal to 1. So alpha d will be equal to this. We have to find alpha, so dividing d on both sides, so we will get 1 more d ln of I divided by I naught. All of these three values are given: d zero point 0.1, I 10 kilo, and I naught this. So we will get the answer for the alpha. Okay. Okay, now this is the example related to the work function. Okay, the role of the positive ion. According to this example, the work function of cesium is 2.14 electron volt. We have to determine the maximum kinetic energy and the speed, kinetic energy and the velocity v, okay, of the electrons ejected from the surface of the cesium. Okay, these are actually the electrons knocked out from the cathode surface. Okay, so we have to find the speed of the electrons and the kinetic energy of these electrons required for these electrons to knock out the electrons from the cathode surface. Okay, and by light of wavelength, okay, we have used this, so means the photoionization. Okay, photoionization, not the collision ionization but the photoionization. So kinetic energy, okay, equal to h mu minus pi. What does it mean? It means kinetic energy plus phi will be equal to h mu. Okay, so how much h mu is required? This is actually the light which will be fall on the electrons. Okay, so some of the energy of this h mu will be utilized in the work function to knock out the electrons from the cathode surface, which is made up of cesium. Okay, and the rest of the energy will be used in the kinetic energy. Okay, in the kinetic energy of the electrons. Okay, photon h mu must be greater than the work function of this material, and must be greater than the kinetic energy. Some of the energy must be left behind so that electrons get the kinetic energy to move to the anode side. Okay, so this is actually the formula. Okay, total is the photo energy. Some of the photo energy will be utilized in knocking out the electron from the cesium atom, and the rest of the energy will be used in the kinetic energy for the movement of electrons towards the anode. Okay, so uh, h mu is given. H is the Planck's constant. Okay, and this is actually the frequency. So converting this h mu into h c by lambda in the form of lambda. Okay, f is equal to c by lambda. So h c by lambda minus phi. Phi is given. Okay, work function of the cesium. This is given. Okay, so h, this is h, this is c, this is lambda. Okay, 10 to the power minus 9. Okay, and this is actually in electron volt, but this is not in electron volt. So to get this energy in electron volt, we have to divide by the E, so that its value is also in the electron volt. Okay, this is in electron volt, so this must be in electron volt. That is why we have divided this whole thing by the charge of electron to convert into electron volt. Okay, because this will be these all the rest of the values are the SI units. So the value of this will be in joule. So convert this joule into electron volt. So we have to divide by 1.6 10 power minus 19 to get the whole value in electron volt. So now electron volt minus electron volt will be electron volt. Okay, so 2.28 minus 2.14, you will get 0.14 electron volt. Kinetic energy is equal to half mv square. From this we have to multiply 2 over here, dividing m on both sides and squaring both sides, so we will get, this is actually the speed. Okay, 2 kinetic energy over m. Char m is the mass of the electron. So this is actually the, so if you want to convert this in the SI, so again multiplying this value with the, this time we have to multiply with the charge of electron because we are converting it to SI. To convert to electron volt, we have to divide it by 1.6 into 10 minus. And in order to convert into SI, so we have to multiply the this value electron volt value with the, multiply with the 1.6 into 10 minus 19. Okay, so this time we have to multiply this. So this is 2, this is kinetic energy converting into the joule. Okay, because 1 electron volt is equal to 10 raised to power minus 9, 1.6 10 raised to power minus 19 joule. This is the relation between the electron volt and the joules. Okay, this is the smallest, electron volt is the smallest unit of the joule, small unit. Okay, another example. Okay, which is very much similar to the previous one. In this the work function is given, now the kinetic energy is given, and we have to find the speed. So it is easy from the previous because work function is given, kinetic energy is given. Okay, so we have to find this, so which is very simple, again using the previous, the formula of the previous example, this one. Okay, but in the previous, in 3.3 we have to find the kinetic energy, but in 3.4 the kinetic energy is already given, so we have just to find the speed by this formula. So this is easy. Okay, so if you have any question you can ask. Yes, you know, this is the last class of the midterm, and from the last class we'll have the midterm exam. Okay, I'm taking the attendance. Okay, you have no questions, sir. I am leaving the meeting.
एक्सक्यूज मी सर
Yes,
एक्सक्यूज मी सर
yes.
सर मैं नज़ीर बात कर रहा हूँ सर ऑनलाइन क्लास है ना सर सॉरी ऑनलाइन एग्जाम होगा सर
जी ऑनलाइन एग्जाम।
अच्छा सर कितने पेपर के कितने दौरान है यानी कितने हॉर्स होंगे सर एक पेपर के हाँ
अभी तो मैं श्योर नहीं हूँ, मगर मेरे ख्याल में 24 आवर्स होंगे।
अच्छा अच्छा सर
जी,
थैंक यू सर थैंक यू सर
24 आवर्स होंगे। आपको
अस्सलाम वालेकुम
Google
सर।
जी वालेकुम सलाम।
सर एनी आइडिया कि पेपर कब से स्टार्ट होंगे?
नेक्स्ट वीक से इंशाल्लाह।
नेक्स्ट वीक।
आपके साथ डेट
चलिए
शीट
ठीक है।
शेयर कर दी जाएगी, जो रूल्स होंगे वो भी इस वीक के एंड तक आप लोगों के साथ शेयर कर दी जाएंगी। ठीक है,
चलिए थैंक यू सर, थैंक यू सर।
ओके।